many years ago where the two sample stuff, it just takes a hot minute to write. Okay. Two samples. Oh, I'm sure you were also just shocked about that information when you walked in and saw that we were going to do that. I bet you know what we're going to do on Friday. Anybody know? Difference. Yep, one sample D. One sample D. Anyway, okay, state four things. Oh, and when you're talking about a difference in means, the hoe is always the same. Just like when we did proportions, it was always assuming no difference, meaning that when you subtract them, it's zero. There's no difference between them. Um, and I'm just going to add that you can label for the problem if you want to avoid having to say what each thing, what one is and two is. And as we learned from that FRQ, you can label them numbers because remember that was like fourth grade and fifth grade. Anyway, so you can label them letters, you can label them numbers. It doesn't matter. It's just whatever label works for the problem. Um, for the ha, you have three options: greater than, less than, or not equal to. Okay, now some of you guys told me that you like to do this separately. You don't like to say mu1 minus mu2 equals the true difference in means. You like to say mu1 equals the mean, the true mean of blank, mu2 equals the true mean of blank. You'll notice my homework is like that because I did the most. I think this is less writing, so I do this. But again, it doesn't matter. Whatever your preference. And then alpha equals something. Okay, pausing there. How do you feel about that situation? Are you guys okay? Do all the things I wrote make sense? And you guys understand if you came in late, real quick, I want you to know that when I say can label for the problem, it means that you can make those letters like, Squishmallows minus little boo-boos. Yeah, that's what I'm going with today. Or whales minus sharks or something like that. Okay, plan. Let me see. Two sample t-test for mu1 minus mu2. This one, I'll leave 1 and 2 because that's like a method. It's a title. Just don't forget to put separate samples. People were still not quite doing that on the chapter 9 test. Some people were not. Okay, write it separately, write it separately, write it separately. Should you write it separately? You should definitely write it separately. Should you put those little like quotation mark things underneath so that like, no, no. You ever write something so many times that you feel like perhaps maybe it wasn't necessary to do the whole notes on this particular? Yeah. Okay, we do need to talk about the large counts because there's two samples. Okay. So there's three possibilities in a large count situation for this. But if both sample sizes are greater than or equal to 30, you're golden. Your COT applies, check, move on with life. Or one of them is less than 30 where you have to do one box plot or dot plot, or both of them are less than or equal to 30 and you have to do two box plots or dot plots. Does that make sense? Okay. That's all I wanted to say about that. Now, if you noticed your plant growing experiment, arts and crafts business, just notice the sample size of that start to feel sad immediately. Okay, now the do step. We have to be a little bit careful here. Some people had some forgettings about in the chapter 9 test, they kind of forgot about the numerator of the standardized test statistic. So we're here, we're in chapter 11, standardized test statistic. That's T equals. You need to use this formula for chapter 11. And the statistic in this case, okay, so this is where we need to be really careful. If my parameter is with 0, but I'm doing a difference of mu1 minus mu2, what would my statistic for that be? Mu1 minus mu2, what would the statistic be? X bar 1 minus X bar 2. So you just change them both into X bars. But that is the statistic itself. Same thing when you're doing chapter 10 for some reason, maybe tomorrow at this time, and you're doing the statistic in the front of the confidence interval. That is one number that is X bar 1 minus X bar 2. Just, throwing that out there for no reason. Okay, anyway, parameter is 0 because that is what was in your null hypothesis, that there's no difference over. Okay, and then standard error of the statistic. Okay, flip your paper over. Chapter 11 is this guy here, the two sample guy. And remember, the numerators of that are squared. And remember, when you're doing degrees of freedom for a two sample, this also applies to T star that you might use, I don't know, say tomorrow at this time. For a two sample, you use the smaller of the sample sizes. Do you guys know of which I am referring? T star? Inverse T, parentheses, 1 minus confidence level divided by 2 comma degrees of freedom, smaller sample size for n minus 1. Just throwing that out there. But the standard error is still this guy, which is great. Okay, anyway, conclude. And do you guys understand my idealio with the top things go together and the bottom things go together? Okay. Okay, so here's my question. Is any of this surprising? If you were in like a focus group and had to like brainstorm what you thought a two sample t-test for mu1 minus mu2 might look like, would this have been it? Would your focus group have gotten derailed about some other topic, like maybe what crackers are best? The answer to that is extra toasty Cheez-Its, by the way. There's a clear answer. There's a clear answer. What are your favorite crackers? I like them when they're a little burn on the what? Hmm. Do you like goldfish? Oh, totally Cheez-Its. But I'll eat both, don't get me wrong. I'll eat them right now. All of them. Every single one. What about the Ritz? Oh, mini saltines are so good.
Be serious, Karen. Are we serious? Are we serious?
Okay, so I have a question. Um, how fancy do you guys want to get the calculator? Okay, so. Okay, let me display, and you guys, I'm gonna let you guys choose. So while you're doing your arts and crafts, we discuss the options in the calculator. Usually when I teach this, I'll have people put one sample into L1, run one variable set, and graph the box plot. Clear that information, and then put the second sample in L1 run one variable stats and do the box plot. Okay, we have options though. We could, if you're feeling spicy, and I don't know how spicy you're feeling, we could put this in L1, this in L2, run two variable stats, get both of the summary statistics, turn two box plots on, and trace two box plots at once. There's a difference in complication, like complicatedness. Yeah, if you.
Let's do whatever John wants to do.
So this is what I'm gonna say. Why don't I show you the fancy way? It's on video, but you guys can always just do L1 and then do everything for L1 and then clear it out and then do L1 again. I mean, that's always an option for you, but I can show you how to do the other. Um, okay. I have to turn my notebook over, but there's nothing else at the bottom. Are you guys okay with me turning the notebook over? Okay. Okay. So let's save the fun calculator bit for a minute. State. Oh. Huh. Um, okay. So I'm gonna go back and look at the letters. Looks like I'm gonna use metal and classical. And I'm gonna go metal first because it says it first and classical second because it says it second. So I'm gonna go the mean of metal minus the mean of classical equals 0. The mean of metal minus the mean of classical. I didn't even read the problem. That's great. Good studying techniques there. Okay, so let's see. Experiment 10 being randomly assigned. Ooh, random assignment. Amount of growth, blah, blah, blah. Okay. So do the data give convincing evidence of a difference? Not means not equal to. Doesn't say anything about does one grow more than the other. Okay. Am I going to remember to multiply by 2? That's a good question. Did it give me an alpha? No? Yes? Are you guys okay with the state? Does the state make sense? Okay, what if you're doing a confidence interval problem? How would you state it instead? Let's just pretend it said 95%. Perfect. I heard it. Well, Vanessa's got it. Okay, plant. Only thing that would change there would just be the word interval. Are you guys okay so far? Okay, so now grab a calculator. Make sure you make yourself do this because we're gonna do fancy business here. Everybody ready? Okay. Mrs. Talbot, it's something new and different. What? Okay, now I'm gonna flip my notebook book back over because I need to see the numbers. I'll bring it back, I promise. Um, okay, I'm gonna go stat, enter, clear anything out that you have in there. I'm going to put the metal numbers in L1. That's not L1. Why am I struggling? Three. That poor plant. Okay, now the classical. You guys ever tried this experiment where you play music for plants? It's like a classic elementary school, like science fair deal. Okay, everybody put your metal numbers in L1 and your classical numbers in L2. You guys with me so far? Anybody need more time? Okay, you're gonna go stat calc, but instead of choosing one variable stats, you're going to choose two variable stats. And you're just gonna ignore the fact that it says Y. You don't care about that, but you want the first one to be L1 and the second one to be L2. You don't want anything in the frequency list. That should be blank. Go down to calculate. Okay, and I'm gonna go back over to the do step. I left a lot of space for the plan because of the box plots, but for the do step, I'm gonna write down this is X bar 1, the top one. And so that's metal, which is 38.2. And S of X for the metal is 27.7. Okay, and then if you scroll down on your calculator, you can see X bar Y, which is the L2 list. Don't call it Y bar, call it X bar classical is 85.8, and S of X classical is 42.5. Does everybody see where I got all that information from? Does that make sense? It just did them separately. It called it X and Y, but we don't care about the names. We just want the numbers out of it. Are you guys completely clear on those four? Okay, so now go to the stat plot again. So go second Y equals, and you're going to want to turn two plots on at once. So hit enter. This, if you have your own calculator, this should still be on from yesterday. This should be on with the box plot with the outliers. And then go second Y equals again. Go down to stat plot number 2. And choose that one. Same thing. You want the box plot with the outliers, but you want your list to be L2. Do you guys know how to get L2? Second 2. Take a look above the numbers that has the lists. You see them? Okay, and then when you got that situated, do zoom 9. And voila. 2 box plots. Okay, so I like to use the same x-axis for both because I'm lazy. So I'm going to start by making my x-axis. So I'm going to hit the trace button and scroll as far left as possible. That's 3. Clearly, that one was 3. And then I'm going to scroll as far right as possible. The maximum was 124. So I'm going to make my x-axis go from 0 to 130 by tens. I think I left too much room, but that's not a bad thing. On your chapter 10 test tomorrow, I'm going to be looking for a label on your graph. But as I said, I made it dot plottable. You do not need to do box plots. It's very quick dot plot. But I am going to be looking for a label. What do you label it if it's one sample? You would just say growth, right? Or whatever, growth from whatever, metal. If it's 2 sample, you'd have to do 2 separate ones. And if it's a difference, you say differences. Do you guys know what I'm talking about? It's a mu D. Okay. Anyway, So I'm gonna go back here to the trace steel 3, 12.5, 36, 65, 73. Oh, that was pretty symmetric. The other one, well, well, well. We're just gonna pretend we didn't see that. $19, 48.5, 87, 122.5, 124. How do you feel about the fancy way? Do you like it? It's really not that bad. But you guys, if you hate it, you realize you could just do everything in L1 and then clear it out and then do everything in L1 again. Okay. T equals statistic 38.2 minus 85.8. That's really kind of a big difference. Minus parameter over okay, pause there. Do my numbers make sense where I put them, how they're situated? Also, did I do it correctly? I think so. Okay. And this one you can do in one fell swoop if you put the top in parentheses like we wrote it, or you can hit enter after you do the top. I got negative 2.1. Okay, now if you're taking a test, I would expect you to get nervous right at that moment because you got right at the alpha level, except nice. Have you guys gotten any, had any homework problems where the p-value is scientific notation lately? Okay, keep your eye out for those because they will happen in this chapter. Do you guys know what I mean by that? Like you get the E whatever, put times 10 to the, and the, scientific notation's tiny numbers. So it's less than alpha pretty much every time. Just throwing that out there. Two of a differential function. Okay. Okay. Write that down and then take a look at my special challenge for you. I have given you a special challenge. It says special because it's special. Okay. After you get the conclusion written down, I'd like you to try to find back in your notebook the notes for interpreting p-value and try to interpret the p-value as best you can for this scenario because we need to be doing it so that you don't forget. Everybody. One of those things, you don't use it, you lose it. Like Mrs. Tava with Spanish every year, every year. I'm gonna freeze the screen and do it myself, and then I'll put the answer up in a couple of minutes. Give it a go. Get that? Do a little bits at a time. Mhm. After the special check, you didn't even write anything.
I found it.
You found the skeleton.
Low hypothesis.
Did I say the word getting in there? Getting, the word getting?
Yeah.
I did, okay. Because last year I wrote it different and I want to change it to getting.
Yeah, just my chance. You know, everything, well.
I hear some really good stuff. There is some spicy bits on this problem. Go, 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 go. Um, okay, I'm gonna show you mine because I hear some wrong things. Okay. Okay. So assuming, so you can't just write the whole, you gotta write what the whole is saying. Yeah, so assuming no difference in the mean growth of plants exposed to metal or classical music, that's what mu1 minus mu2 equals 0 says in words. Assuming no difference between 1 and 2. There is a 0.10 probability. Hey, I got that. You guys said that. That was good. That was good. There's a 0.10 probability of getting a difference of sample mean. That's your statistic. That's your X bar for this poem. It's not just X bar, X bar 1 minus X bar 2. Negative 47.6. And then the thing is, it's two-sided. So you can't just say or more or less. So I put or more extreme to cover both sides. Just by chance, and then you guys said in a random sample of 5 bean plants, but there wasn't a random sample of 5 bean plants. It was random assignment. So you have to say it was randomly assigning 5 bean plants to each unit. You see the critical thinking that was required here. That's why it was special. It's not you, it's the scenario. But I just want to talk about, like, you know, how you do that with weird different stuff. How do you do it with two-sided? How do you do it with a difference? How do you do it with random assignment? It's very different than your usual, but hopefully that makes sense. Good job. Good job. Now, while you're finishing that, that is the end, by the way. While you're finishing that, I want to find the joke. I'm hoping it's decent. I don't actually know. I forgot to open it up this morning. 1 second. Let me look for it. You did not. I refuse to believe that you fit it all on one page. I'm so impressed and jealous. That's the 38.2 minus 85.8.
Oh, I get it.
Yeah.
Here is my joke. Go back for like 2 seconds. Oh, I will go back, don't worry. It says, statistics, study shows 6 out of 7 dwarfs are happen. Where did you? This is my joke. I don't know why, did you see it? No. Did something come up? Okay. Does this make sense though? 6 out of 7 dwarfs aren't happy? Like, the Snow White and the 7 dwarfs, there's one of them's name is Happy. Oh, aren't happy. 6 out. Oh, it's not the 6, 7 thing. No, it's literally, his name is Happy, like, 6 and 7 of them.
Yeah.
Okay, but wait, when is that homework due? Friday, because you have to still do your MCQ. Please don't forget about those. They're so sad and lonely out there. Oh, waiting for you to click their buttons. They're like, please come read us and click the correct answer. Please. We're so sad when you forget about us out here, lonely. On the internet. What?
Two things.
The cows? Is it the cows?
No, I like the cows.